Okay, now let's do this in the computer. Let's have problem number 28. It's about the sleeping bags. I already have the sleeping bag file over here, so let me open it. Basically, we have the model of sleeping bags, we have the temperature rating, and we have the price. And we are going to run simple linear regression in order to find out the regression equation, the strength of the relationship, the correlation coefficient, the coefficient of determination, and the ANOVA table, and basically that's it. Okay, let's go to data analysis, and we are going to find out regression over here. Regression, hit OK. Okay, why range? Remember, it's important that you identify the dependent and independent variable. The dependent variable is the Y range. In this case, the dependent variable is going to be price. Why? Because price is going to depend on the temperature rating. Let's do this. The dependent variable goes in Y, and this is price. Let's hit this. The X is the independent variable, and we are going to select rating as independent, and we are going to hit levels because this the data that I gave have labels on the first row. And we are going to include the regression analysis over here. Hit OK, and you're going to have everything that you need to know about this regression. First of all, what is the regression equation? You are going to find the regression equation right here in the coefficients over here. The intercept is my B0, and the rating is my B1. This is the slope. This is a negative slope, and the intercept is 359. So in this case, my equation is my dependent variable, that is in this case is price, is equal to 359.26 minus my slope, that is negative 5.277 x, but in this case x is the rating, the temperature rating. So this is my regression equation. Price is equal to this, or this is y and this is x. Okay, this is the formula for my linear regression. Now, the next thing that I need to know is what is my correlation coefficient. Is my R, and that is my correlation coefficient. What is my correlation coefficient? No, this is not. This is not. This is R squared. R squared. This is R squared. 0.8043, and we know the correlation coefficient is the square root of the. R is the square root of R squared, but with the sign of the slope. Okay, now. The R square, remember, R square is the percentage of the variance explained by the independent variable. So it says that 80%, because this is 0.80, 80% of the price really depends on the rating, the temperature rating. The other 20%, well, it may come from the material, for the weight, many other factors that may influence the price. Okay, now we want to know how strong is this regression. We can use the two ways. The ANOVA table immediately tells you that this is significant, so we reject the null hypothesis and we say that B1 is really definitely different than 0. So we do have a strong regression equation between the two variables. The other one is by using the t-test, using the B1, that is negative 5.27, divided by the standard error of the slope, and that is equal to negative 6, and the p-value is exactly the same. So, but this is a t-test and this is an f-test. This f-test has 1 degree of freedom in the numerator and 9 degrees of freedom in the denominator, because we have what? 11 data points. Is not, we are not going to count these plus these. These are 11 data points that we have. So that is why n minus 2 is 11 minus 2 is equal to 9. And this is my f, and this is the significant value. So we reject the null hypothesis and we conclude that there is a strong regression or linear regression between these two variables. Basically, that's it. You don't need to know anything else, basically.